Hey friends, welcome to one of the last slots here in at EclipseCon. I hope you all enjoyed the conference, and I'm quite overwhelmed that so many people made it to this talk. So thanks for that. And quick disclaimer: a few of the stuff that I wanted to show after I prepared the presentation and thought about it was already presented in the previous days. So information about records and pattern matching, etc. was already covered. So I made a few tiny last-minute adjustments, but I hope it's nevertheless entertaining as well as insightful, and hopefully there's something to take away for you from this as well. So to get a better feeling on where we stand together, who of you is a Java developer, engineer? Excellent. Who remembers writing code in Java 1.3? Still impressive. Who's already on Java 17? Who uses Java 19 preview features in production? No, this was just an it's not me, not my fault. I didn't do it. Okay, so this is kind of a journey over the past years of Java evolution, language evolution. My name is Sebastian, and I'm a self-employed consultant from the Berlin area, but these days this doesn't really matter. Since 2008, I'm committed on the Xtext project, so I have had my fair share of breaking changes in languages since then. Since Xtext is a tool that allows to develop domain-specific languages. Since 2001, I was writing Java code for money, so I remember all the good stuff: remote method invocation, swing, JBuilder 4.0, rename refactoring by doing search and replace, all this stuff. Beautiful. These were the days. Language evolution. What is the important part of language evolution? What do we have to keep in mind when we think about it? Certainly not, well, maybe, it depends on your viewpoint, certainly not what the C# people did. So when C# emerged, it was a smallish language, and then they took each and every opportunity to put all the stuff into it. I think one of the languages that has all the features would be this. Not my prime example for decent language evolution. There are other ways to approach new language releases, like the Scala people did at the beginning. New minor release, recompile all the libraries. Yay! Similar to nowadays Spring Boot releases when you update all your POMs. So things to consider when you release a new version of your language. Is it backwards compatible? Do we break our ecosystem? Or are we even able to make a new release? So, anyone familiar with Perl? A few. So, these people are working since the year 2000, apparently, Wikipedia told me, on something that was called Perl 6, after Perl 5, so evolution. They gave up. It's now called Rake. So sometimes decisions that you made are hard to fix. And sometimes ideas that you have are hard to implement. Others don't really care. So I can picture the Python people thinking about next iteration of Python. So should we make a Python 3? Or maybe we should make a Python 3, but it would break all the things. We can't do that. Let's go it. And this is an approach that really can harm an ecosystem. It wouldn't break it, because Python nowadays is still very, and even more popular than ever, I would say. But it can really hinder adoption if your new fancy ideas break existing code or are not compatible to what used to be there. So what do we have to consider when we talk about language evolution? First of all, what are the features that we want to do? Do we need lambda expressions in Java? Was probably very apparently something that would have been answered with yes right from the very early days. But there are other things that need to be considered. So not only what kind of features do we want to put into it, but are those features backwards compatible? backwards compatibility is just crucial. When you look at the Eclipse ecosystem, one of the key assets that we had over a very long time, and somewhat still have, is the upgrade path to new versions. When it used to work, API didn't disappear, didn't break, it was stable, it was rock solid, it was backwards compatible. Changes have been made with with existing clients in mind. And this is not only necessary for open source libraries, it's even more necessary for the languages that you use to write code. But if it's backwards compatible, it's not necessarily sufficient. There's another question that needs to be answered, and this is the question, would this change be forward compatible? Are we putting something into this language that would make it tremendously harder in the future to evolve the language further? Is this something that would be a roadblock for one of the future ideas that we have now but cannot implement because of some random constraints that exist in the real world? But would this still be possible after we did this tiny change here that we can do? And of course, if the answer is no, this wouldn't be forwards compatible or this wouldn't be backwards compatible, don't do all the breaking changes in a single go. Do it with consideration. Let's take the example of the underscore identifier in Java, which was first deprecated, then it became a warning, and then it was basically invalid Java code from Java 9 on. So it took 2 major releases to phase out a feature that would be in the way of future enhancements to the languages, to the Java language. What constitutes the Java language? What do we have to evolve when we make a new release? I think the most obvious part is if you do syntax changes. So of course the language itself has to be evolved. When you make when you allow deconstruction patterns, you have to make grammar changes. So this is what is in the face of the user. But the Java language is way more than just what is written in code and allowed to be written in code. It's the Java virtual machine that interprets bytecode. So it's also the bytecode level. It's the compiler that makes bytecode out of source code. It's the spec that, if things go well, explains how the compiler should work and how the JVM should interpret bytecode. And it should be in sync and aligned with all the implementation that exists. It's a standard library, so we're already at 5. The standard library that needs to evolve as well. If you make patterns into the Java language, you probably want to update the standard library to allow to ask whether a certain, or if you make records, the better example, you want to ask whether a certain class is a record or not. So you need to enhance the API in a backwards compatible way. Then there are other tools that exist as part of the Java language. Annotation processing tools. When you make records, you probably want to annotate those and see in the annotation processing API that these are records and do special treatment for those. Then there are tools that allow to provide insights over a running JVM process that probably need to know about lightweight threads suddenly when you make lightweight threads. So mission control, flight recorder. The Java doc tool needs to be updated when records are enabled. Command line tools like JMap and the other one that decompiles the code, JP something, Java P. All these things have to be evolved in lockstep to make a new Java release when you do a significant or even a tiny change to the Java language. And of course, there's the Java enhancement process that drives all the coordinated effort and ensures that each and every language change is fulfilling the requirements and doesn't do more than was expected, and explicitly states what is not supposed to be in this single release. In a nutshell, this is hard work. A very hard coordinated effort is necessary to make a new Java release. So 90% of my preparation time went into this timeline because Google Spreadsheets, no, Google Slides is amazing at these things. So back in the days, That was the first release of Java, and we had a few, actually a nice release cadence of approximately roughly 12 months to make it a language that was actually usable. So we introduced, or someone introduced, serialization in Java 1.1, which will haunt us still until forever. Then there were a few useful additions, like collections API was added, so it became actually something that you can work with without the need to write custom collection implementations. Reflection API to introspect the class. The JIT compiler, just-in-time compilation, appeared first in Java 1.2. And from 1.3 on, so when I started writing Java code, Windows support was there, so I had a Windows machine. And you could actually debug the code. And the hotspot JVM was first released with 1.3. Then we had this time, anyhow, with 1.3. That was a quite popular release. And we had this extremely popular library to write tests, JUnit 3. And they had this very nice API that had a method called assert, and you could write readable tests like assert, Boolean condition, text, or the other way around, assert. And then something happened with 1.4. An engineer at Sun had the idea we could have assert statements in Java, so let's break one of the most popular libraries out there by introducing assert as a keyword. That was quite an effort. Upgrading from 1.3 to 1.4 was fun for all the projects that had a decent set of tests, because at those days, refactoring tools, yeah, you probably, either you remember or you don't want to know. It was bad. And they spent time on other important things like Java util logging and, and really important things like Neo. So the language evolved further, but mostly on the API level. 5.0 was a game changer. So Java got all the good stuff that we used that we still benefit from, and that somehow also lay the foundation for a few of the enhancements that are nowadays possible. So we got generics without the generic type information being available at runtime. That was a deliberate decision, a carefully made decision. And it was based on the premise that we have to have something that is backwards compatible. It might not be what you design on a green field. It might not be what you wish for, but it might be something that solves problems. So the approach that was taken towards generics is something that Brian Gertz nowadays outlines as, we looked at all the stuff that was there and tried to figure a solution that is doable and helpful for the user and doesn't get in the way. And over time, it will just work, because everything raw type will eventually disappear from code bases. And eventually disappear, like we are still not there, but he's somehow right with this assessment. Sometimes the best solution is the one that is not the best, but the best compromise. Also other stuff was introduced, annotation, auto-boxing, useful. With Java 6, the annotation processing tools appeared and were kind of standardized, and a lot of performance improvements on the JVM have been made. That was a huge leap forward. And then the kind of dark ages of Java started. So we took a break with language evolution. Worked harder, and came up with Project Coin, so tiny language improvements, try with resource, diamond operator. But also, and this is something crucial here, the Invoke Dynamic bytecode instruction first appeared in Java 7. And that is key to plenty of advancements of the language that happen nowadays. I will come back to this. From here on, we got the Java 8 release. Who's still on Java 8? And any plans to update? Is it possible for you to update? You should. Anyhow, that was a enormous step forward for Java as a language and put new life into the Java ecosystem. We can probably say that like this. And again, similar to how generics work, for Lambda expressions and method references, all the information was used that was available to the team that spec'd out the feature to figure out what is the most useful approach towards Lambda expressions in Java, and how can we do it beyond the naive approach that others would take, like the xtext-based extend language, where we had Lambda expressions and simply compiled those to anonymous class instantiations. This could have been the spec for Lambda expressions as well. This is just syntactic sugar for anonymous classes, full stop. But they didn't do it deliberately. That's why it took so long. They fought hard in the standard committee to find a way to make it backwards and forwards compatible and future-proof. So the approach was to base the compilation of lambdas and method references not only on syntactic desugaring towards anonymous class instantiations, but it was based on the Invoke Dynamic bytecode instructions. The learning that was applied is, if we don't know yet the perfect way to compile Lambda expressions, then we just don't compile them. We postpone the decision to a later point in time, meaning at runtime, and the first naive implementation at runtime could just be that an anonymous inner class is being made at runtime, but it's not in the bytecode. The bytecode is decoupled from what happens. And this is one of the best decisions that they made so far. So basing the new features on something that can be improved later on without breaking changes. So we got Nashorn, which was the kind of test kit for Invoke Dynamic performance. Nashorn being the JavaScript implementation running on the JVM, everything untyped, everything Invoke Dynamic, making sure that this is reasonably fast was probably this was probably just an exercise to make lambdas fast. That would be my very positive interpretation of this feature disappearing 2 releases later. There was probably another idea behind it, but it didn't take off. Anyhow, we got the module system. Who's benefiting from modules? They are not always right. Those things happen to the best. But yeah. We got the var keyword, local variable type inference. Why this is not deserving so much of a rant as the enum and the assert keyword before, we'll come back to this. And the release cadence was changed to a 6-monthly period where we have long-term releases and preview releases, long-term supported releases. And as you can see, and as you are probably even more familiar with than I am, new features arised in a very fast paced, and not always in their final shape, because we now have this concept of preview features that allows to gather feedback from the community, that allows to postpone a final decision even further, because we gather more information. And then at some point, these things become sealed and finalized, these specs. So without going into details of all the good stuff and great stuff here that was already covered at the conference, let's talk about a little more about how they make certain decisions. And with they, I mean the people that are working on the new Java versions, on the new ideas that deserve to go into language. We are in an extremely lucky position with the Java ecosystem that there's so much code out there and open source available and in binary form available, that Oracle is and the others that are collaborating there, they're in a position to analyze tons, and you cannot measure it in tons, but they can analyze all the code out there to see how Java as a language is being used and to identify the patterns and idioms that need to work flawlessly and to identify all the corner cases that could potentially break, but would in practice not break because no one is hitting those. Doing data mining on Maven Central and GitHub is a key factor in the decision-making process when new Java features are being discussed. And always with the goal, how can we make something that is better for the average boring code? Let's make the code more boring. We don't want to make the code more exciting. It should be trivial, you should see it and understand it, and everything's good. Preview features help a lot to understand how a certain approach is being accepted and whether it gets effectively in the way or fulfills its promise. And something else that they also did often, and not to the which often doesn't please the Twitter sphere, they postpone things. If they are not sure about a certain design, it's not going into the language. Prime example being text blocks that are just boring text blocks. After 3 iterations, they are still boring text blocks, and everyone was complaining that there's no expression embedding in these strings, and there's no fancy format support, etc., etc. They were not there yet, and now they have a good idea, so they're putting it on schedule again. So if you're unsure about a feature, whether it carries its own weight, don't do it. And that is one of the best ways to evolve a language. Be very careful and be sure what you're doing. When we look at this in the bigger scheme of things, then we can see certain patterns that we follow in the evolution of the language. So sometimes there are very small changes, like nestmates. Anyone here who doesn't know what nestmates are? Good. So it used to be the case in Java, when you write an inner class that accesses properties of the outer class that are private, that these were not visible to the inner class on the bytecode level. So what the compiler did, it inserted additional instructions, additional accessors, made this stuff available in a package private way with something that was called bridge methods. And so it looked as if the inner class could seamlessly access properties of the enclosing instance or enclosing class without breaking encapsulation. But in fact, it did somehow break encapsulation. And it was a weird rule. Yeah, it's private, but my private neighbor cannot see it, but in fact it can. And so what they did, they simplified the rule. If it's nested, it can access the outer stuff. Nothing changed from the outside. All the stuff is still the same for the developer, but on the bytecode level, it shaved off a few instructions, and it made the language more regular. Next step, you work on the statics. So I can have a static class within a static class, so nested classes are allowed, but I cannot have a static class in a method. But I can have an enum in a method, and the enum is static. And I can have records, which are always static. So it isn't regular. So what they did, they refined the spec and said, okay, we can nest statics within instance methods and instance classes, and the semantics are just that we cannot access the instance properties, but we can nest it syntactically. So statics can go into a method, and we can have fully lazy initialization and all the good stuff without any. So you can do even better singletons than you could before, if you are into singletons. Fact is, they removed restrictions that were artificial to make the language more regular, easier to understand, and impose less questions for the user, being experienced user or first-timer. And when you go further with this more regular approach to a language, you end up with the Hello World example, as usual with language explanations. And we remember the days when we first had to write our very first Hello World program, and it was like, yeah, just do public static void main, string, squared brackets, args, and then do your Hello World. And we explain later what this is. And everyone was like, okay. And in fact, there's no good reason to make this more complicated than strictly necessary, but it was more complicated than strictly necessary from a today's standpoint. And then with the JavaScript and Kotlin approaches, everything was just, oh, I can write my function and things are good. So what we are going to see in future Java versions is that that it is possible to write functions on the top level, so methods on the top level without an enclosing class, and we will see that the main method itself has a relaxed signature, so the args, if I don't need it, I can leave them out, and it doesn't necessarily need to be static anymore. So ceremony around the Java language syntax is going to be removed, and especially the entry barrier is going to be reduced. So what we are going to see is that this is valid Java code in one of the future versions. And it's the perfectly same code as before. No need anymore for the public static void main. And system out, who cares where the system out comes from? We can have an implicitly available static import for system.out. And this is some sugar that they're going to apply to reduce the entry barrier towards Java development. So if you would see this code, you wouldn't have guessed that this is Java code. But it is, or it will be. Another thing is language evolution in terms of new keywords that we introduce. So this is fine. Of course it is. I wrote this. So you have the var keyword, which is no longer allowed to be a name of a declared type, but it is still allowed to be the name of a local variable, or the name of a method, or the name of a field. So we have restricted identifiers, which is a new concept and superior to, let's break all the code that used var somewhere. Of course, they could have made var a keyword, but after analyzing all the code on GitHub and GitLab and whatnot, they figured var is used quite often in user code, so better not break those. Make them happy. And they figured var is a very rarely used type name. So it's fine. That's why they introduced a contextual keyword, a restricted identifier, which is allowed in some places but not in others, but still basically a regular identifier, and indicates local variable type inference. And since we're on it, Java 19. Questions? And of course, IDEs, parser generators, JDT, has a hard time with this because of technology baggage. But in the end, it boils down to the question, what kind of syntactic construct is allowed here? And if this is a type guard, then this must be a type name, and we give it an alias. And then we have the pattern condition that's introduced by the when keyword, or we don't have a pattern condition, then there would be an error. So it's a contextual keyword, a restricted identifier that is allowed in almost all places, but if it appears here, it's a keyword and introduces the pattern. Syntax coloring helps. Decision making, when you evolve a language, is based on not doing the obvious sometimes. Not doing the obvious is the best idea that you can have. And if there's no better idea, then don't do it, as I already mentioned. So for text blocks, we will get variable interpolation, but on steroids, and not in the naive way that other languages might have done it. And again, the escape sequences here, these are based on research. What kind of text was used in strings in the wild? Can we use dollar parentheses, or should we use something else? // square brackets, and they did the math, and the least intrusive change would be to use / curly brace, because the allowed characters after the / are already limited in format strings. So far, it is not possible to write / curly brace in that way. So it's actually a backwards compatible change, and it's a variant that requires the least practically not the least, but the very few escape sequences when you don't want to have this to be an expression that is embedded in a string. You might wonder what this is. This is the stuff that puts this on the next level, so to say. So this is the context in which the template is being interpreted, and the outcome must not necessarily be a string. You can also make a richer structure that is like a SQL query or something else. It all depends on the way the string template, which is not a plain string, is being interpreted. So they went through a lengthy design process to come up with something that is more regular and more powerful than the naive solution, without the need to break the naive solution later on. This is not finalized yet, but something like this is likely to come. I'm running out of time. So, what they learned is basically what is there is good, and what is there right now is the hotspot JVM, which defers certain optimizations from the bytecode level to the machine level until runtime, when all the statistics have been gathered and it knows what is the hot path to the code, what is supposed to be jitted. They basically do the same now for the compilation when Invoke Dynamic is used rather than direct bytecode instructions. By compiling to Invoke Dynamic, it's basically putting a recipe into the class file that is interpreted by the JVM later on to make the, at that point, best bytecode possible. This strategy was taken for lambda expressions, as I already mentioned, for optimizing string concatenation, for records, which are compiled in a very smart way because there's no overhead from all the methods that you don't use on a record. So if you never put your record instance into a hash map, there won't be a hash, or a hash set, or if you never call hash code, there won't be a hash code method. Because it's only, the bytecode is only made on demand when it's first called, meaning that the hash code itself can be optimized later on. If there will be a smarter way to compute hash codes for objects in Java 29, then all records that have been compiled with Java 17 compilers would still benefit from this. And the same is true for pattern matching, where we not see a naive linear check of all instance offs in the bytecode, but it's done at runtime to find the correct cases that are supposed to be seen. What does this all mean in the big scheme of things? We are seeing kind of a shift from regular, boring, object-oriented programming to regular, boring, object-oriented programming or data-oriented programming. So polymorphism is useful for a few cases, and other cases where you have immutable data, like records, combined with the language features that are to come and did come already. We see an approach towards implementing solutions that decouples behavior from the data structure itself. I couldn't say it better than Brian Goetz in this article. Highly recommend it. It's a nice read, probably more than 5 minutes. But it boils down to the idea that we not necessarily need to put all the behavior on the instances and objects that we are making, but we can have generic reusable data structures, and depending on the use case, we can implement the behavior decoupled from those by means of pattern matching, sealed classes records, stream processing. How this looks in practice, this is a random guy from the internet, and he used swear words in OR, so I didn't put them here, but basically he said, this is amazing, and I think it is. Because even though we don't have a clue what all these types are and what these do, there's no such thing as big methods that are supposed to be called and no polymorphism is involved. The entire solution to put this expression, which we don't really know, into a SQL string is in this single method, basically in this expression here. So we have case statements, we have patterns with special filtering, we have patterns that are the fallback if there's no special condition within the end. And it all makes sense in the big scheme of things. Even though it was not released together, each and every piece of the puzzle during the Java language involution leads to code that feels natural, even though a little scary at first, and is nice. Running out of words. The takeaway here should be the approach to backwards compatibility with the restricted identifiers is, from my point of view, nice. From the compiler engineer's point of view, maybe not so nice. Backwards compatibility is key to the entire thing. I didn't go into serialization, but serialization affects each and every decision that is made for the Java language evolvement. So bad decisions are hard, they will haunt you. And we shouldn't be angry if not all the wishes are fulfilled in the same release. And the remaining minute will be used for begging, begging for more support for the team from the Eclipse Java compiler. This is a crucial piece in the ecosystem. It's the second implementation of the Java language compilation. It's like proofreading the spec. It's proving that the ideas work. It's so necessary for this ecosystem to strive and survive in the very long run and be robust against accidental changes to the language. The maintenance of the Eclipse Java compiler is something that is, I cannot emphasize more how important it is that this tool in its current level of quality survives and is evolved further. And yeah, as you might have noticed during this conference, there is a lack of resources. So if your company bets on Eclipse technology in one way or the other, do the risk assessment, be careful with saying someone else will do it, because everyone is saying someone else will do it. Almost everyone. And the few people that are standing up and working on Eclipse technology, on the Java ecosystem within Eclipse, these people, they disappear. It's just like that. We have to be careful. The entire dance is extremely challenging for the small team that is working on the Eclipse Java compiler. Are there any questions? Two more minutes. Catch the train, please. Thank you.